Hello, my name is Farrar, and this is Podcast 2, Limits and Asymptotes for Dr. Lewis's Calculus 1 class. The first problem we are given is the limit of x approaches 0, tan 2x over x is equal to. So how we start this problem off, we have to substitute in 0 for x. So we have tan 2 times 0 over 0. All in all, this is 0 over 0, and we cannot have that. Once we find out that it is 0 over 0, we know that we have to switch how the equation looks. So instead of having tan, we will have sine over cosine. So sine over cosine, we're still going to have 2x, because it's just tan x written in a different form. And we still have that x that's already in the denominator. This is equal to the limit of x approaches 0, sine 2x over x cosine 2x. Now, we're going to split this into two different equations. Limit of x approaches 0. We have sine 2x over x times 1 over cosine 2x. Now we have to have a common denominator, so we're going to multiply this equation top and bottom times 2. Now when we multiply it times 2, we're going to have the limit of x approaches 0 is 2 sine 2x over 2x times 1 over cosine 2x. Once we do that, we cross out this because this is just equal to 1. So now we have the limit of x approaches 0 is 2 times 1 over cosine 2x. Now we can finally plug in 0 again. Once we plug in 0, we have 2 times 1 over cosine 2 times 0 equals 2 times 1, which equals to 2. So that's how you have the first problem. That's how you solve the first problem. Number 1. Now for number 2, it has the limit of x approaches negative 8 from the right, 2x plus 8. First thing you do, you want to plug in negative 8. So we have 2, negative 8 plus 8, which equals negative 16 over 0, and we cannot have that. So in this situation, we know that it will be either positive infinity or negative infinity, and to find that out, you have to look at a chart or a graph. We have negative 8, negative 9, and negative 7. The rule is we have to go 0.5 from the actual distance, and since this is approaching from the right, we're going to stop at 0.5 right here, which is negative 7.5. We will be unplugging this negative 7.5 into the equation. So the limit of x approaches negative 8 from the right is equal to 2 times negative 7.5 over negative 7.5 plus 8. The top is going to be negative, the bottom is going to be positive, but it's negative over positive. The answer is negative infinity. To find the vertical asymptote of this equation, we will set the denominator to 0. So the original equation is limit of x approaches negative 8 from the right, 2x plus 8. This is the denominator. Set the denominator to 0. We subtract 8 from both sides of the equation and have the vertical asymptote is equal to x is equal to negative 8. So that's number 2. Number 3, we have the limit of x approaches infinity, 4 minus 3x squared over square root of x to the 6 minus 9. First thing we do, we're going to plug in infinity into the equation. So we're going to have 4 minus 3 times infinity squared over infinity to 6 minus 9. When we do this, we're going to get negative infinity over infinity. We cannot have that. So now we have to divide the whole equation by the highest denominator, the highest exponent, which is limit x approaches infinity. We're going to divide 4 by x over 3 because that's the highest exponent, minus 3x squared divided by x cubed. In the denominator we have 6x minus the square root of 6x minus square root of 9. And we're going to divide this by square root of x to the 6, square root of x to the 6, because square root of x to the 6 is equal to x cubed. Once we do that, we have the limit of x approaches infinity is equal to 4 over x cubed minus 3 over x all over square root of 1 minus 9 divided by square root of x to the 6. Now we can plug in infinity. Once you plug in infinity, the numerator gets you 0, and the denominator gets you 1. 0 over 1 is 0. So the answer for number 3 is 0. And the horizontal asymptote for this one is HA equals Y equals 0. For the next couple problems, we'll be using this graph. to find the limit of x approaching -4. So when we look at -4, we look for the left and right. And since there is not a point right here, then the limit does not exist. Looking at x, the limit of x approaches -4 from the right. We're approaching from the right, and we see that this function is going towards infinity. And looking at x approaches -4 from the left, we're looking at this function that is approaching negative infinity. For number 5, it's asking for the limit of x approaches infinity. We're approaching infinity. We're going this way, and we see that this reaches -1. And as the limit approaches negative infinity, we see that this function is approaching it's approaching 2. So that is the problem for the answers for number 4 and 5. And this is my podcast.